Good morning to all of you. This is Somshekhar, Assistant Professor of Mathematics, Sarami Government Science College, Bumunkate, Bhadravati. Welcome to my fifth session of the unit Successive Differentiation, which comes under the chapter Differential Calculus. In the last session, we did some problems on finding the nth derivatives using these four standard functions. In this session, we are going to prove the famous theorem, Leibniz theorem. Without wasting the time, let me come to this theorem. Before going to this theorem, this is important to know about these points. When the subscript is 0 and the superscript and subscripts are same, then such combinations are 1. If the addition of two combinations are like this, that means the superscript is same and the subscripts are the successive terms, r minus 1 and the next term is r. If the superscript is same and the subscripts are the successive terms, then the addition of such combination is superscript becomes m plus 1 and the subscript becomes the highest term r. This Leibniz theorem states, and this theorem is for the nth derivative of the product of two functions. How can we get the nth derivative of the product of two functions? If u and v are two functions of x, and suppose the nth derivative of u is un and the nth derivative of v is vn, then this theorem says the nth derivative of the product of these two functions u into v is equal to the nth derivative of u, first function, into second function v plus nc1, the n minus 1th derivative of first one u. In the next term, ಒಂದು ಡೆರಿವೇಟಿವ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಫಸ್ಟ್ ಟರ್ಮಲ್ಲಿ, ಸೆಕೆಂಡ್ ಟರ್ಮಲ್ಲಿ ಒಂದು ಡೆರಿವೇಟಿವ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಹೋಗುತ್ತೆ, ಯು ಎನ್ ಮೈನಸ್ 1 ಇಂಟು ದ ಡೆರಿವೇಟಿವ್ ಆಫ್ ಸೆಕೆಂಡ್ ಒನ್ ವಿ 1 ಪ್ಲಸ್ ಎನ್ ಸಿ 2, ಇಲ್ಲಿ ಒಂದು ಡೆರಿವೇಟಿವ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಎನ್ ಮೈನಸ್ 1 ಎನ್ ಮೈನಸ್ 2 ಇಂಟು ಸೆಕೆಂಡ್ ಟರ್ಮಲ್ಲಿ ಒಂದು ಡೆರಿವೇಟಿವ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ವಿ 1 ವಿ 2 plus etc. plus the last term is NCN u into the nth derivative of v, second one. Now call this as 1. Here I have to prove this result is true for all positive integer n. Here n is positive integer because the derivative starts from 1, u1, u2, u3 like that, and that means here n is a positive integer. Now I have to prove this result for all positive integer n. For this I use the mathematical induction principle. In the PUC level we already know this rule. First, to prove the result, for n is equal to the first value. Here the first value is 1. The positive integer starts from 1. So first prove the result, whatever we want, for n is equal to the first value 1. Then assume that the result is true for n is equal to m. Then prove that this result is true for the next term of m, that means m plus 1. First prove the result for n is equal to 1. Assume that 1 is true for n is equal to m, then prove that 1 is true for n is equal to m plus 1. And this means that this result is true for all positive integers. First of all, now I am proving this result for n is equal to 1. That n is equal to 1. This 1 becomes uv1 is equal to, here n is 1, u1v plus, here n is 1, 1c1. Since the superscript and subscripts are same, the combination is 1. 1 into, here n is 1, 1 minus 1, 0, u0. u0 means no derivative of this function. That means the original function u into v1. If n is equal to 1, 1c2, here n is 1, 1 minus 2, u minus 1. Here u minus 1 is meaningless. Minus 1 derivative of u is meaningless. And that means this 1 is valid up to the second term, uv1. And this is the first derivative of the product of two functions, and we already know this. First function u into the derivative of second, v1, plus second function v into the derivative of first, u1. That means, and this result is valid for the first derivative, which is true. Therefore, and this 1 is true for n is equal to 1. Now assume that 1 is true for n is equal to m. That is, whenever n becomes m, the LHS is equal to RHS. And this is my assumption. UVM is equal to, replace n by m, UMV plus, here n is m, MC1, here n is m, um minus 1 v1 plus mc2 minus 2 v2 plus mcm uvm. These two are equal, and this is my assumption. Now I have to prove, and this result 1 is true for n is equal to m plus 1. That means I should get like this. Whenever n is replaced by m plus 1, LHS should be equal to RHS. UVM plus 1 is equal to, I should get like this. Here n is m plus 1, um plus 1v plus m plus 1 c1. When n is m plus 1 minus 1 gets cancelled. Um v1 plus m plus 1 c2. When n is m plus 1 minus 2 minus 1. um minus 1 v2 plus etc. m plus 1 c m plus 1 u v m plus 1. I should get RHS as like this, and LHS is u v m plus 1. Now I have this. Differentiate both sides with respect to x. Now we have, this is the mth derivative of uv. If you differentiate mth derivative, you get m plus 1th derivative. If you differentiate first derivative, you get the second derivative. If you differentiate second derivative, you get the third derivative. That means in the subscript 1 is added. The derivative of mth derivative is, in the subscript 1 is added, it will be m plus 1th derivative. M plus 1th derivative of uv is equal to, use the product rule. First function um into the derivative of second v1 plus second function v into the derivative of first. The derivative of mth derivative is m plus 1th derivative. That means in the subscript 1 is added, um plus 1 plus MC1 is a constant into, again use the product rule, first function um minus 1 into the derivative of second v2 plus second function v1 into the derivative of first, the derivative of m minus 1th derivative. That means the 1 is added. Minus 1 plus 1 gets cancelled. It will be um plus mc2 into the first function um minus 2 into the derivative of second v3 plus second function v2 into the derivative of first, the derivative of m minus 2 derivative. That means 1 is added to the subscript. Minus 2 plus 1 minus 1. It will be um minus 1 plus etc. plus mcm is a constant. Here also use the product rule. First function into the derivative of second, the derivative of Vm, it will be Vm plus 1 plus second function Vm into the derivative of first one, U. Now this is equal to LHS. I already got UVm plus 1. Now in the RHS I should get, when n is m plus 1, when n is replaced by m plus 1, the first term becomes um plus 1v. So in this equation, first collect um plus 1v. Collect the terms accordingly when n is replaced by m plus 1, because in the RHS I should get the format where n is replaced by m plus 1. In the first term, it will be um plus 1v. So collect um plus 1v. Here it is um plus 1v plus. In the second term of the equation 1, when we replaced by n by m plus 1, it becomes m plus 1 minus 1 m ಆಗುತ್ತೆ um into v1. So in the second term, collect the terms um v1. um v1, here it is here it is in the first term um v1, and also here is there um v1, mc1 um v1. Now take um v1 common, it will be 1 plus mc1 plus, in the third term when we replaced by n by m plus 1, it will be m plus 1 minus 2 m minus 1 v2 um minus 1 v2. Collect those terms. um minus 1 v2 ಎರಡು ಕಡೆ ಇದೆ, um minus 1 v2 um minus 1 v2. Now take common um minus 1 v2. The remaining is mc1 plus mc2 after taking um minus 1 v2 common plus etc. In the last term, when we replaced by n by m plus 1, it will be m plus 1, it will be u vm plus 1. This is the last term. Collect u into vm plus 1. The last term is u into v plus 1. Here it is. Now mcm u into vm plus 1. Call this as 2. The equation 1 and the equation 2. Observe these two equations. Here, apart from the constants, the equation 2 exactly matches with the equation 1 when we replaced n by m plus 1, when we replaced n by m plus 1. The only thing is, I have to match these constant terms. I have to match these constant terms. When n is replaced by m plus 1, in the first equation, it will be m plus 1 c1. So I should get 1 plus mc1 as m plus 1 c1. Similarly, this combination should be equal to m plus 1 c2. And similarly, this combination mcm, I should get this as m plus 1 cm plus 1. Now 1 plus mc1 is equal to, that means I should get 1 plus mc1 and this combination in terms of m plus 1. In the first equation, when I replaced n by m plus 1, the combinations are in m plus 1. So I should convert these combinations where the superscript is m to the superscript m plus 1. Here is the conversion. 1 plus m, I can write 1 plus mc1 as, I can write 1 as mc naught. Since the subscript is 0, the value will be 1. mc naught plus mc1. Now this is of the form, superscript is same and the subscripts are the successive terms. So the addition of this type of combination is superscript becomes m plus 1 and the subscript becomes the highest term. I already told you this format. When superscript is same and the subscripts are the successive terms, the addition of this combination is superscript becomes m plus 1, subscript becomes the highest term. And definitely these are the same format. Superscript is m, subscripts are the successive terms. Therefore, the addition of these combinations is superscript is m plus 1, subscript is the highest term. Now I can put 1 plus mc1 as this one. Now consider the second combination, mc1 plus mc2, but I have to convert this to m plus 1. Here the superscript is same and the subscripts are the successive terms, and therefore the addition is m plus 1 c highest term 2. Now I can put m plus 1 c2 in place of this one. And lastly, mcm is equal to, here superscript and subscript are same, so the value will be 1. Similarly, m plus 1 c m plus 1. Here also the superscript and subscripts are same, and therefore the value is 1. Both these are equal because these two amounts to 1. Now, in equation 2, put these values. Now, equation 2 implies LHS is UVM plus 1 is equal to UM plus 1V plus, in place of 1 plus MC1, put M plus 1 C1, M plus 1 C1 UM V1 plus, in place of this, put this value, M plus 1 C2 UM plus 1 V2 plus, in place of this, put M plus 1 C M plus 1 UV M plus 1. Now, I have the equation where LHS and RHS are equal when I replaced n by m plus 1. And therefore, and definitely 1 is true for n is equal to m plus 1. So by mathematical induction principle, 1 is true for all positive values of 1. And this is the proof of the Leibniz theorem. Here are some exercise problems based on the Leibniz theorem. Please go through this and follow these references. Thanks for watching and see you in the next session.